Yet again, a tremendous scene is spreading out as we talk, enchanting stargazers all over the planet. Betelgeuse, the entrancing red supergiant that decorates Orion's shoulder, is undergoing an important change. This magnificent giant, known for its mind-blowing red hue, has been a hallmark of the winter sky for ages, drawing the awe and wonder of stargazers from ancient civilizations to modern astronomers. What makes this change so remarkable isn't just the transformations occurring within the star itself but the sheer scale and speed with which they are happening. This immense star, typically much larger than our Sun, is showing us just how dynamic and unpredictable the universe can be. Betelgeuse's brightness, the brilliant glow that defines its radiant presence, has surged beyond its usual brilliance by an astonishing 50%. Imagine a light suddenly burning twice as bright, casting its radiance farther and with greater intensity. That's what's happening with Betelgeuse on an infinite scale. At the beginning of this year, Betelgeuse proudly held the esteemed title of the 10th brightest star in the night sky. Its consistent, prominent light was a steady feature of the heavens, a beacon of constancy. However, this unexpected stellar flare-up has catapulted it to a remarkable new position, now shining brightly as the 7th brightest star in our dazzling night sky. This leap in brightness has sparked excitement and interest within the astronomical community, prompting fresh observations and studies to understand the dynamics driving this thrilling transformation. Betelgeuse, a massive star in its late stages of life, is of extraordinary size. Its dimensions are so vast that if it were placed at the center of our solar system, it would extend as far as Jupiter's orbit. Eventually, this star will undergo a collapse, resulting in a powerful cosmic explosion that may lead to the formation of either a neutron star or a black hole. The anticipation surrounding Betelgeuse's cosmic explosion stems from the fact that it will be an unparalleled event. Located about 650 light-years away, humanity finds itself in an ideal position to witness this colossal display firsthand. When the stellar explosion occurs, it will deliver a breathtaking display of light. Initially, there will be a sudden surge of neutrinos sweeping across Earth, detectable by observatories worldwide. Following this, high-energy photons will emerge from the expanding cloud of stellar debris. Betelgeuse will rapidly increase in brightness over 7 days, reaching up to 100 times its normal luminosity. Depending on the explosion's power, this celestial beacon could rival the brightness of a full moon and might even be visible during daylight hours, casting distinct shadows at night. This extraordinary event will last for an extended period, offering a unique opportunity for detailed observations and potentially groundbreaking discoveries. While Betelgeuse's cosmic explosion may provoke speculation and fear, historically linked with ominous signs, we can take comfort in the fact that we are safely situated at a significant distance, shielded from any harmful effects. To fully grasp the mystery surrounding Betelgeuse, it is essential to revisit the end of 2019, when certain peculiarities began to emerge. During this period, the red supergiant star experienced significant dimming, a change noticeable even to the naked eye. Observations using the Very Large Telescope in the optical range revealed that Betelgeuse appeared relatively unchanged, yet its photospheric layers showed signs of major disturbance. The photosphere represents the outer layer of the star where light is emitted. Scientists also identified an expansion of the photosphere, giving the impression that the star was growing. When observed from Earth, this expansion continued at a steady rate of about 8 kilometers per second for most of the year until mid-November 2019. By then, the outward velocity began to decline. By mid-November 2019, the flow of material from Betelgeuse ceased, prompting astronomers to capture new optical images of the star. Their observations revealed two remarkable anomalies. First, a darkened region appeared in the star's southern hemisphere, creating a striking contrast with a previous image taken earlier that year. Second, the surface temperature of the star underwent a significant drop, decreasing by about 80 Kelvin between January 27 and February 13, 2020. The brightness of Betelgeuse reached an unprecedented low. Roughly a year after the cessation of the outflow, the star gradually regained its brightness over the following months, eventually returning to its standard luminosity. This led to the question, what had truly happened with Betelgeuse? All the available evidence strongly suggested that Betelgeuse had undergone an epic and rare event known as a surface mass ejection, SME. This phenomenon bears similarities to coronal mass ejections, CMEs, observed on the Sun. To better understand SMEs, imagine a volcanic eruption on a scale matching that of a star. Material from the star's interior surges outward, causing shock waves within its atmosphere. Over time, this material forms particles and dust, partially obscuring our view of the star and making it appear dimmer. In Betelgeuse's case, the SME resulted in the release of a mass 400 billion times greater than what is typically seen during similar events on other stars or CMEs. This amounted to several times the mass of the Moon, ejected at astonishing speeds. Scientists observed that such a massive mass release from a star's surface had never been witnessed before. The event allowed for direct observation and analysis of surface details using the Hubble Space Telescope, providing a unique insight into the aging and evolution of a dying star. The SME had a profound impact on Betelgeuse, causing it to lose a significant amount of mass in a single event. This demonstrated that a dying star could experience major mass loss beyond its normal annual decline due to solar wind. In a way, Betelgeuse had effectively shed its outer layers and was now slowly recovering from the aftermath of this event. However, following this dimming event, the star's behavior underwent a transformation. Previously, it would pulsate or shift its brightness at regular intervals, but now it is pulsating at irregular intervals. Betelgeuse is classified as a semi-regular variable star, meaning it experiences multiple cycles of varying brightness due to changes in its size and temperature. This red supergiant is known to exhibit two primary periods of light pulsation. The first period lasts approximately 400 days and is believed to be caused by pulsations in its fundamental mode. The second, shorter period occurs on a timescale of about 185 days and is likely driven by higher-order pulsation modes. However, following the 2019 surface mass ejection, Betelgeuse's pulsation patterns became less predictable, a clear indication that the star had undergone significant internal and external changes. Astronomers have closely monitored these irregular pulsations, hoping to decode what they reveal about the inner workings of the star. Betelgeuse's behavior is a reminder of the delicate balance between gravity and pressure in massive stars, as well as the unpredictable nature of the end stages of stellar evolution. The fascinating and unprecedented changes in Betelgeuse have also prompted discussions about its ultimate fate. When a star of its size reaches the end of its life, it can no longer sustain nuclear fusion in its core. Gravity eventually overwhelms the outward pressure, leading to a catastrophic collapse of the core. This collapse triggers a supernova explosion, releasing a tremendous amount of energy in a matter of seconds. For Betelgeuse, this process could happen at any time, whether in a few years or a few 100,000 years. When it does, the supernova will produce a brilliant light display visible across the galaxy. The event will also generate heavy elements such as gold, silver, and uranium, enriching the interstellar medium and contributing to the formation of new stars and planets. The aftermath of Betelgeuse's supernova will likely leave behind a dense remnant, either a neutron star or a black hole. A neutron star, formed when the collapsing core becomes densely packed with neutrons, would spin rapidly and emit intense radiation beams. Alternatively, if the core's mass exceeds the neutron degeneracy limit, it will continue collapsing into a black hole, a region of spacetime where gravity is so intense that nothing, not even light, can escape. Despite the uncertainty surrounding when Betelgeuse will explode, the ongoing observations of its behavior provide valuable insights into the life cycles of massive stars. Betelgeuse's recent changes have challenged existing models of stellar evolution and prompted new theories about the processes that govern the late stages of a star's life. As humanity awaits this spectacular cosmic event, Betelgeuse serves as a celestial laboratory, teaching us about the dynamic and ever-changing nature of the universe. Its story is a testament to the interconnectedness of all things in the cosmos, how the death of one star can pave the way for new beginnings elsewhere. In the meantime, scientists and stargazers will continue to watch Betelgeuse closely, marveling at its brilliance and speculating about its eventual demise. This iconic star, a symbol of wonder for countless generations, reminds us of the immense scale and beauty of the universe and our place within it. A longer example of around 5.6 years, and its starting point remains hazy. In their exploration, researchers utilized computer simulations to gain a deeper understanding of the events that occurred. They suggested that a surprisingly hot gas flow, resembling a large and extraordinary bubble, rose from within the star. These events of hot gas bubbles periodically emerge due to the star's convective envelope operation, which can be likened to a pot of boiling soup where the material is constantly moving and mixing. As this hot bubble rose and broke through the star's surface, it triggered the release of stellar material. Interestingly, it also disrupted the star's normal pulsation pattern. The star's surface continued to expand while its deeper regions contracted, causing the star to shift from its usual 400-day pulsation cycle to a new 200-day cycle. Astronomers expect that the star's normal cycles will gradually stabilize, with the irregular pulsations likely returning to the standard multi-day cycle over the next 5 to 10 years. Regarding the possibility of a Betelgeuse supernova explosion, astronomers speculate that it could happen anytime within the next 10,000 to 100,000 years. Based on factors such as the star's color, brightness, size, and estimated age, experts suggest that Betelgeuse is currently in the early stages of helium-to-carbon fusion. This process will continue through oxygen and finally to iron before the star's core collapses under its own gravitational pull, leading to a catastrophic explosion. Since Betelgeuse is located 650 light-years away, any cosmic explosion occurring now would only become apparent to us 650 years later due to the limits imposed by the speed of light. Thus, it is highly unlikely that we will witness the star's dramatic destruction during our lifetime. The remarkable thing about Betelgeuse is that we can actually observe its surface, which is not typically possible with most other stars. This offers us an incredible opportunity to learn how massive stars like Betelgeuse behave as they age, including events like these rare mass ejections. Recently, astronomers made a startling discovery. They observed a star consuming its own planet 12,000 light-years away in the constellation. Betelgeuse, with its captivating name and prominent position in the night sky, has fascinated human imagination for centuries. Its significance extends beyond scientific knowledge, influencing popular culture and folklore worldwide. Betelgeuse has a rich and diverse origin rooted in the Arabic language, originally interpreted as the armpit of the giant. Some researchers argue it may refer to a hand or shoulder instead. This physical association is reflected in various interpretations of Betelgeuse, often linked to human or animal figures across different cultures and legends. Betelgeuse carries complex meanings and symbolism. In ancient Japan, it represented a severed limb, while in Brazil, it was seen as a turtle's leg or a caiman's hind leg. The Sanskrit word for Betelgeuse means the moist one, tied to Hindu astrology's Ardra lunar mansion and associated with the storm god Rudra. Since ancient times, Betelgeuse has played a significant role in cultural practices and traditions. For example, in Macedonian tradition, it represented domesticated animals and agricultural life in villages. In regions like North Baffin Island and Melville Peninsula, its rising marked the beginning of spring and longer days. Betelgeuse's cultural prominence stems from its association with the constellation Orion, where it is recognized as the star on Orion's right shoulder. As one of the brightest stars in the sky, ranking 11th in luminosity, it dazzles and inspires artists, writers, and creators. Scientifically known as Betelgeuse, it continues to captivate astronomers and enthusiasts alike with its recent changes and the potential for a future supernova explosion. Prominently situated in the constellation Orion, Betelgeuse has been a celestial symbol for centuries. Its reddish glow and variability have captured the imagination of cultures worldwide. In recent astronomical history, Betelgeuse's unpredictable behavior has been particularly notable. Its variability in brightness has been closely observed, revealing insights into the late stages of massive star evolution. This variability, once thought to follow a predictable pattern, has surprised astronomers with its recent changes in pulsation periods and unprecedented dimming events. One of the most significant observations in recent years was Betelgeuse's dimming event, which began in late 2019 and continued into early 2020. This dimming caught astronomers off guard as the star lost a significant amount of its usual brightness. The fading was visible to the naked eye and measurable through precise observations using advanced telescopes. Such events are rare for a star of Betelgeuse's size and have prompted intense investigations to understand their underlying causes. Scientists have proposed several theories to explain Betelgeuse's dimming episodes. One leading theory suggests that the dimming could be linked to the release of material from the star's surface, potentially caused by convective processes deep within its interior. These processes correspond to massive bubbles of hot gas rising through the star's layers, disrupting its normal pulsation, and leading to the ejection of stellar material into space. These convective cycles within Betelgeuse's interior are akin to enormous waves of energy that create disturbances both on the star's surface and in its immediate surroundings. Such activity is not only significant in understanding Betelgeuse's behavior but also provides insights into the life cycles of other massive stars in the universe. The released stellar material, combined with the convective dynamics, alters the star's brightness, shape, and pulsation periods in ways that are still being closely studied by astronomers. Betelgeuse's dimming event in 2019 to 2020 is thought to have resulted from a combination of factors, including a large cloud of dust formed from material expelled by the star and a temporary cooling of the star's surface. These factors likely worked in tandem to obscure Betelgeuse's light, causing the dramatic drop in brightness that fascinated scientists and the general public alike. In the aftermath of this dimming event, Betelgeuse has continued to recover, gradually returning to its typical luminosity. Observatories around the world, including space-based telescopes, have focused on Betelgeuse to monitor its ongoing fluctuations. This continued attention has made Betelgeuse a prime example of how massive stars can surprise even seasoned astronomers with their dynamic and unpredictable nature. Looking to the future, Betelgeuse's eventual supernova remains one of the most anticipated cosmic events. When it does occur, the explosion will likely be one of the brightest phenomena visible from Earth, potentially outshining the Moon for weeks. The light from the supernova will provide an unprecedented opportunity for astronomers to study the death of a massive star in extraordinary detail. It will also serve as a natural laboratory for understanding the physics of stellar explosions, the formation of neutron stars or black holes, and the enrichment of the surrounding interstellar medium with heavy elements. Despite the vast timescales involved, Betelgeuse remains a powerful symbol of the interconnectedness of the cosmos. Its presence in the constellation Orion has inspired countless myths, legends, and scientific inquiries over the centuries. Whether as a bright guide in the night sky or as the subject of cutting-edge astrophysical research, Betelgeuse continues to be a source of wonder and discovery. As humanity looks to the stars, Betelgeuse reminds us of the dynamic and ever-changing nature of the universe. The star's story, of formation, transformation, and eventual demise, mirrors the cycles of life and death that occur on both cosmic and personal scales. It is a humbling reminder of our place in the cosmos and the fleeting yet profound beauty of existence.